This section is on rates, and rates can be used to compare two or more items by writing unit rates. So we saw how to write ratios. Now we're going to look more into unit rates, which we touched on a bit last lesson. So a car travels 240 kilometers in 3 hours. So we could write this, I'm going to write this as a fraction because usually with speed, things like this, it's nice to write as a fraction. So we have 240 kilometers in 3 hours. So we have kilometers on the top, hours on the bottom. As a unit ratio, what we would do for each one of these values is we would divide each one so that I get a 1. And typically with these ones, well, at least for kilometers per hour, you want per hour, 1 hour. So you want 1 hour on the bottom of the fraction. So what did we do? Well, we took 3 and we divided by 3. So we take 240 to get the top, and we divide that one by 3 as well because it has to be an equivalent ratio. You cannot divide or multiply the top and bottom by different numbers, the numerator and the denominator. You will get a different fraction, a different value. So I divide 240 by 3, and I get 80 kilometers, right? So this car is traveling at a rate of 80 kilometers per hour, average. A cheetah can travel 1 kilometer in 30 seconds. 1 kilometer per 30 seconds. So it looks like we already have a unit ratio because we have a 1 on top. But I kind of want to figure out how far or how fast it can travel per second. Now, because the value on top is in terms of kilometers, I would rewrite this actually in terms of meters. So I get 1,000 meters in 30 seconds. Okay, because now I want to figure out how many meters per second this cheetah travels, because cheetahs can't travel that fast for that long. So what am I going to do? I want 1 second on the bottom. So I take 1,000 and I divide by 30 because I divide both by 30. So I divided that one by 30. I take the 1,000. I divide it by 30. And I get about 33.3 repeating meters per second, which is really fast. So 33 meters in 1 second is really, really fast. So that's how to write unit ratios, or unit rates, I mean. We divide both the top and the bottom by the same amount, and typically you want a 1 on the bottom of your rate. And this is really useful, as we'll see in this example, because we can compare items that have different sizes. But if we break it down to be so we can compare the price per the same size, then we can see which one's cheaper, which is the cheaper option. So the price per 100 liters. So for the first one, I see this is probably ice cream. So I have an ice cream container of 400 milliliters, and that costs me $5.49. So I have $5.49. And that's per 400 milliliters. Okay, so to get per 100 milliliters, to get the price per 100 milliliters, I would have to take the bottom and divide it by 4. So I would take the top and divide it by 4 as well to compare these. So I have $5.49 divided by 4. So I get $1.37. Okay, so $1.37 per 100 milliliters for the first one. For the second one, this one here, I want it per 100 milliliters. This one's a little more complicated because it's 730. So to take 730 and get it in terms of 100 milliliters, I would take 730 and I would actually divide it by 73. No, sorry, 7.3. So I take 730 and I divide it by 7.3. You could find this out too by dividing 730 by 100 to see how I get to 100. I divided by 7.3. Okay, so to get from 730 to 100, I divide by 7.3. And the price, $6.50, I'm going to divide it by 7.3 as well. So I get $6.50, and I divide it by 7.3. And I get 89 cents, 0.89, and that would be like in dollars. The last one here is $7.75, so I'm going to get it per 100 milliliters. It's in 1,000, So to divide 1,000 by 100, we can divide those two. So I take 1,000, I divide by 100, and I know I'm going to be dividing each one by 10 this time. So I take 775, and I divide it by 10 to get 77.5. So I'll round up, about 78 cents. So 0.78. And that's in dollars too. So we can see that this last one here, is the cheapest option because it's 78 cents per 100 milliliters. This one's a little bit more, 89 cents, and the first one was $1.37 per 100 milliliters. Okay, so that's how you can compare those per 100 milliliters. Per 1 milliliter, I think I'm going to leave to you. You would basically just divide each one of these things by the amount of milliliters. So the first one you divide by 400, the second one you divide by 730, and the last one you divide by 1,000. But sometimes it's nice to have in terms of 100 milliliters. But often if you go into a grocery store, you can look at the label and it'll tell you how much it is per 1 milliliter too. So that's helpful. Okay. Now we're going to look at travel and gas. So a van can travel 700 kilometers on one tank of 80 liters of gas. So we have a van, and it can travel 700 kilometers on 80 liters of gas, so 80 liters. The truck can travel 800 kilometers. Trucks tend to have bigger gas tanks than vans, and it would take 120 liters of gas. So we have kilometers on top, liters on the bottom. Compare these two fuel economies. So we can either get these, well, if they were larger amounts of fuel, you get it per 100 liters. In this case, we're going to get per 1 liter because that makes way more sense to get it in terms of a unit ratio. So both of these, we're going to break down per 1 liter of gas to see which ones has the best fuel economy. So this one we can see right away from 80 to 1, I divide by 80. So I'm going to have to take the top and divide it by 80 as well. This one here, I'm dividing it by 120. So I'm going to have to take the top and divide it by 120 as well. So for the first one, 700. I'm dividing it by 80 because I divided the bottom by 80. I get 8.75 kilometers per liter. So this van can travel 8.75 kilometers on every 1 liter of gas. The truck, if I take its fuel economy, I divide by 120, so I take 800, and I divide by 120 for this one, and it gets about 6.67, we'll say. And that would be kilometers per 1 liter. So we can see that the van has better fuel, what we call fuel economy. Okay, so the van has better fuel economy because it can go farther, 8.75 kilometers per 1 liter, than the truck that can only go 6.67 liters per kilometer. Okay, another example. 6 bagels are going to cost you $5.45, which is a better deal, or 8 bagels for $7. Okay, so we'll look at the first one first, 6 bagels for $5.45. So we want to get both these in a unit ratio, basically. So I want to figure out how much 1 bagel is for this option. Okay, call this option 1. So for option 1, for 1 bagel, we divide by 6. So we're going to have to take the price, the total price of $5.45, and divide it by 6 as well. So 1 bagel is about 91 cents. And the second option, we have 8 bagels, so I want to figure out how much for 1 bagel. For $7, so I'm going to divide that by 8 because I want to get 1 bagel. So I divide the price by 8. 7 divided by 8 is about 89 cents. For about 89 cents. Okay, so option 2 is cheaper. Not by much, but it is cheaper. You'd have to look at to see what kind of bagels these are. Are they the same bagels? If they are the same bagels, then that's a good then it is a bit cheaper. So, and if you're buying like 30 or 40 bagels for a big group, a big family event, then it might be a good to go with option 2. It'll save you more money. Okay. Second to last example here. So me, Mr. Hell, my van takes about an hour to travel to Merritt. It's about accurate, which is a distance of about 80 kilometers from Kamloops, which is where I'm from. If he travels by himself, though, and takes his Ferrari, which I have, of course, it takes 35 minutes. So what is the speed of each vehicle? So first of all, for my van, it takes 1 hour to travel a distance of 80 kilometers. So we put the speed on top, 80 kilometers, and it goes 80 kilometers in 1 hour. Okay? If I take my Ferrari, I can do that same distance. So we have the Ferrari over here. And it can go that same distance, which is 80 kilometers. But this time, it only takes 35 minutes. Okay. So how are we going to compare these two? One's in hours, one's in minutes. Should I take them both in terms of hours? You could do both. You could divide this one by 60 to get in terms of minutes. This one by 35 to get in terms of like 1 minute, how fast it goes per 1 minute. Or we could try to get them in terms of 1 hour. This one's already done. It's already in terms of 1 hour. So to get this one in 1 hour, though, how many minutes are in an hour? Do you know? It would be 60 minutes. So I would put 60 minutes down here, or just 1 hour, which are the same. And to figure out what I multiply that by, I know there's 60 minutes. So if I take 60 and I divide by 35, I'm going to get the amount that I multiplied 35 by is kind of reversed. I'm dividing, but I'm finding the factor that I'm multiplying by to get to 1 hour. It's about 1.71. So if I take that same amount, 1.71, and I multiply it by 80, the top, I get 137.1. So 137 kilometers per hour. So I'm speeding because the speed limit from Kamloops to Merritt is roughly about 120 if you take the Kokola. So we can see, I would probably get these in terms of hours because most people say, how many kilometers per hour do you drive? Right? So it's usually per 1 hour. Okay, so we divided. I took 1 hour or 60 minutes. I took 60 minutes and I divided by 35 minutes to get the scale that I use to multiply this by, right? Okay, last example. So a peregrine falcon, which can travel very fast if it's diving, but let's just say, hypothetically, if it could fly and keep its same speed from Kamloops to Vancouver, which is about a distance of 355 kilometers, in 4.5 hours, we're going to try to figure out how fast this peregrine falcon can fly. It can actually fly this fast, but it probably can't fly that long because it's way too far. So we have 355 kilometers on top. Remember, always put the kilometers on top and the hours go on the bottom. So we put 4.5 hours. I want to figure out how fast this thing is going per 1 hour. So how many kilometers per hour is this peregrine falcon traveling? And I can see that 4.5 to 1, what did I divide that by? You divide it by 4.5, right? Because I'm getting a unit. 4.5 divided by 4.5 is 1. So I'm going to take that same amount and divide the top by 4.5. Okay, so I take 355 and I divide by 4.5 to get about 78.9 kilometers per hour. So that's a very fast for a bird. But I think that's usually if this peregrine falcon is like diving to get food. So hopefully that lesson helps, looking at how to get unit ratios, how they can help to compare two things, especially when it comes to speed of vehicles or animals. You always usually want kilometers per hour, meters, sometimes meters per second as well would be a good one to do if you're dealing with shorter distances, shorter speeds. So we look at kilometers per hour, and that's usually 1 hour. Or if you're dealing with smaller distances, you want meters. And then if you have meters, you typically want meters per 1 second. right? So a smaller amount.